So we're going to pick back up where we left off in section 10.2, talking about displaying data. And we had talked about a histogram, and I'd like to kind of review just a tiny bit about that because it's very similar to what we're going to do on the next one. A histogram, if you'll remember, has adjoining rectangles or bars, so they're right beside each other, connected. The categories are shown along the horizontal and vertical axis. And this was our example of the one that we had done. Frequency is along the vertical axis, and then whatever data that we're comparing is along the horizontal axis. This is usually used for data that's on a continuum, right? So we have grades. I know we can group grades in certain ways, but this is usually used for things that are along a continuum. A bar graph is much like a histogram, but it has spaces between the bars to depict categorical data. So things that we can lump into categories. So if you sort of imagine, we're going to do an example with grades, and that's fine. It's not the best example ever, I promise. But if you imagine some of those sort of like surveys that you fill out, like I know a number of you guys were at McAllister's the other day, and they like you to fill out a survey, and you fill out a survey, you get like $3 off. I always fill out surveys that give me money off. So at the very end of most surveys, they ask for categorical data. So they'll ask you for your household income. They'll ask you for your gender. They'll ask you for your age group, those kinds of things. You know what I'm talking about? Where sort of your actual individual data gets lost in a lump because we don't have that individual data. We only have the category you fit into. That's where you would see histograms used, as in categorical data. So we're going to create categorical data, but kind of imagine, if you will, that you didn't actually have the data to start with, at least not the individual data points. All you actually had was this group frequency. So I'm going to use this group frequency as though that's where we were beginning on our information instead of actually having all the data. Okay, that didn't work. Let me try that again. That's definitely not what I wanted to do. Okay, so this was our grouped frequency table, and I'm just going to have it down there in kind of the corner. I don't think I have, yeah. Okay, so if I'm using this information, what I'm going to have, instead of these categories on the left where I've written out the numerical values, is that they would have letter grades. So the first one that I just erased was the D category. That was the C category, the B category, and the A category. Okay, so we have different categories: A's, B's, C's, and D's. We don't draw them on a continuum if that's all we knew, because we actually don't know if the A's that we have are anywhere close to the B's that we have, right? So when we're drawing this, they're going to be disjointed bars. They're not connected. Other than that, the picture will look a lot like, or practically identical to, the histogram picture. So we're going to draw our X and Y axis, horizontal and vertical axis. Our frequency needs to go up to, I drew it till 10 last time. But when I do my bars at the bottom, what will happen is I need the bars to be equal thickness, but a space between them. So this will be the category for the D's. And it really doesn't matter whether you start with D's or A's, just so you know. You could do it either way. And then I've got a category, same width, for the C's. And then I've got the category for the bar that's the same width or thereabouts for the B's. And then I have a category for the A's. I still need to label everything like before. This is grades, space. I'll label every second unit, so 2, 4, 6, 8, and 10, and this is my frequency. And I draw bars, the same bars I had before, just not touching one another. So the D's were 3. The B's were 2. The C's were 2. The B's were 4. And then the A's were, what was it, 8, 9? 9. That's not great. Let's try that again. So it's the same picture, right? But it's for categorical data. And we would title it just like we did before. These are grades on a second exam. Any questions on that? You don't have to on a single bar graph. We'll need to do something on the double bar graph that we're about to do next to indicate the differences between them, and shading would be an option. Colors are an option too, so it's up to you. It just depends on what you want to do. So, like I said, we are doing double bar graphs next. A double bar graph is kind of like a back-to-back stem and leaf plot. In fact, we're going to use the same data set. We've been using the same data set for most of this. It's a comparison, right? It's a bar graph that allows comparisons. It's still done for categorical data, right? So keeping that in mind, our bars are not going to touch, right? The C, the bar for the letter grade of C is not going to touch the bar for the letter grade of B, that kind of stuff. We had categorical data, and let me just write them down. So on my second exam, we'll go over here. On our second exam, we had 3Ds. We had, it was 2, wasn't it? 2 Cs, 4 Bs, and 9 As. And we're going to do the same thing for the first exam. And that's a ways back. We don't have it right near handy, but we did it back on example 3. We did on example 2 as well. But if you flip back to example 3, I'll flip back here for just a moment. We have the stem and leaf plot for the grades on a first exam. So what we need to know the categories that we have, and we actually have an additional category here, just like when we looked at the stem and leaf plot, we have an F's category on this one, so we are going to need to represent that. But right here we have, and I'll just write them to the side for now, so there's 3 F's, there's 1 D, there's 4 C's, there's 2, 4, 6 B's, and 4 A's. So we're going to just list those. We could make a grouped frequency table with those the same way. That's not being requested of us, but so we're just going to list them. So I have 3, 1, 4, 6, 4. And those are F's, D's, C's, B's, and A's. And again, I'm going from lowest to highest in terms of the grade. You could go from highest to lowest. Kind of depends on the image you're wanting to create. So as we make our double bar graph, again, it looks the same in terms of the horizontal and vertical axes. I'm labeling them same, all of that good stuff. But my horizontal axis will be slightly different. So let's actually make our vertical axis first. I still don't have anything bigger than a 10, so I'm going to use 10 as my upper bound on this. Try to make them as roughly equal as you can as you're going, so that it doesn't look visibly incorrect. So here's the thing on the bottom. We're going to split it into the F's. We have to do F's this time. F's, D's, and so forth. And so I'm going to split my horizontal axis like that. So here's my F's, and then I leave a little space, and approximately the same width. Here's my D's. Leave a little space. Same width. Here's my C's. Little space, B's, little space, and A's. But each of those spaces needs to be divided in half. I need to fit 2 rectangles wide in that space. So if it helps you to go back and sort of subdivide each of those, you can, either physically marking something. I'm going to physically mark mine, or you can just visibly do it as we work. I think my bars might have gotten a little thicker as I went. I apologize for that. I have to zoom in out so much it's hard for me to keep track of that. It's easier if it's all on one screen, but it's just not. So on the first test, I had 3 F's. So I need a bar of height 3 here for the F's. Okay, I'm going to call that good for now. There is no bar of height, anything, right, for the F's on the second exam because there weren't any. So it does end up looking blank. If it bothers you for it to sort of look blank, you're welcome to draw sort of a line down here to represent that you're at 0. And then we're going to skip over to D's. D's on the first test, there's only 1. So I need a bar of height 1. But on the second test, there were 3. So right next to it, touching it, because they're both representing the D's, I need a bar of height 3. And again, they should look like they're approximately evenly widthed. Mine are a little bit off. So I have a 1 and a 3. On the C's, I have a 4 and a 2. So I need a bar of height 4 next to a bar of height 2. Something like that. The B's are 6 and 4. And then I have 4 and 9. And your bars will probably look far better than mine since I have these wonderful rectangle tools, but I can't do everything at once to see it all. Okay, it's close. So we're going to come back to the question that Emma asked about shading now. With all these bars just drawn all in there, that does not give a very good representation of what's going on. It's very confusing to look at. So the first thing I'm going to do is I'm going to do what you could do with shading if you only had one color, like only had a pencil. So you could shade one of the bars, as in maybe like the first test bars, and you could shade them all with matching, shapes of shading. They all have to match. And you'll see why in a moment as we make our key. And then you would shade them, again, same color if you only had the one color, differently for the other bar. So maybe you do it horizontal, maybe you do it vertical, or maybe you do your hash mark, your diagonals the other direction. It doesn't really matter. It's your pick. But you're differentiating them in some way. And if the best you could do was one color with you, this is sort of the best you could do in terms of shading. Now, the reality is, you guys are all education majors, and I would probably say it's a probability of 0 that all of you don't have at least 2 colors in your bag. Agreed? So I'm going to undo all these and show you what I would really recommend you do instead. We'll see how many of I can get them done. It's not the worst situation to do it that way, but it's certainly not the cleanest. So what's better is if you just have 2 colors. It doesn't matter what 2 colors that they are. I've already got a highlighter in green on my screen, so I'm going to use green. So I'm going to let green be my first bars. And then change the color to whatever else you'd like to be your second bars. We'll go with blue. So all my second bars are going to be in blue. And we all agree that that looks better, right? Yeah, it definitely does. A lot more intuitive to look at. We do need to indicate with a key what those blue and those green bars represent, because they don't represent quite the same thing any longer as they did before, where all my bars over here do represent the same thing, right? There's a difference. So if you're doing the key, I'll do my key over here just because I have some space. Just make a couple of boxes and then shade one of them in the color that you did. I've got a blue. And then one in the other, mine was green. And you're writing down what they represent. So the green were first exam scores. I'm still running out of space even as I'm writing. And the blue were second exam scores. So that's my key. I need to go back and add a couple of details to my graph. Namely, these need to be written down that these are grades down here, and that this is the frequency over here. And then what one more thing is lacking? a title. So what this really is it's a comparison, right? So if you want to use the word comparison in there, that's a great idea. This is a comparison of first and second exam scores. Okay, makes sense? Okay, so we've talked a lot. In fact, you just had an exam where you were asked to describe the difference between odds and probability, and many of you went back to the ideas that I gave you about part to part and part to whole comparisons. That wasn't quite exactly all of what that question was asking, but most of you do recognize that there is a part to part comparison and a part to whole comparison when we're looking at ratios. So when we're looking at bar graphs, what we're actually doing is it's like a part-to-part comparison, right? So whether it's this graph where we're comparing the first and the second exams, or this graph where we're just comparing the first exam or the second exams to one another, bar graphs do a really good job, histograms do a really good job of comparing different categories of data. That's what they really do. A pie chart or circle graph, the last one we're going to do, is a far better imagery for comparing a part to a whole of something. Okay, it isn't that it can't compare parts to parts, it's just not the best visual for doing so. It's a far better visual for comparing a part to a whole. So this consists of a circular region partitioned into disjoint segments. This graph shows how parts are related to the whole. Now, many of you have some kind of water bottle or something on your desk, or maybe you can borrow somebody's who are nearby. That's your easiest way to get a circle. So we're going to flip to this example, and you're just going to draw a circle on your paper for right now. Okay, so example 9, I need you to draw a circle. I'm going to draw one as well. I just have the added advantage of it being stored inside my little iPad. So we're going to draw ourselves a circle, and just a reasonable approximation is fine. It's not something that has to be super perfect, but it should not look like an egg, even if it is Easter this weekend. No eggs. So we're going to take this and we're going to cut it into pieces of a pie. I mean, that's really what we're going to do. So the other thing you need to mark on here is where it visually looks like it's approximately the center of your circle. Again, it does not have to be perfect, just an approximation is fine. Okay, we have a whole bunch of data that we're going to need the information on, and we have a little bit of the information already collected for us. It's this one right here. So I'm just going to copy this part of it to the next one so that we can finish out the information that we're going to need. We need to know how many of each of the letter grades we had on that second exam. Now, how many total exams do we have here? How many is that? It is 18. So there's 18 total. So there are two things that we're going to need to do our circle chart or our circle graph. We're going to need the percentage that each of the grades are of the whole, and we're going to need the percentage in terms of degrees. We're going to do the degrees that represents in a circle. So the first thing we're going to do is do the percentages, all right? So if you will, I'm going to sort of make a chart over here, but you don't have to make it as a chart. I just like charts. So we're going to take each of our values, so like 3, we're going to divide it by 18 and multiply by 100. That's going to give us our percent. You can round to a whole number. We don't really need to do decimals. We're not going to be able to do anything decimal-wise to be super specific like that on a graph anyway. It's just not going to be that precise. But if we take 3 divided by 18 and multiply by 100, we get 16.6 repeating. So this is approximately 17%. Now, while that is still saved in your calculator, what I'd like you to do is I'd like you to hit, go back and divide by 100 so that it's back in the decimal form. So 0.16 repeating. And I'd like you to multiply by 360. So this column is my degree column. And the way I get my degree column is by multiplying by 360 degrees. So I take the decimal times 360. that actually ends up being a very nice value for us. What did that give you? It's 60 degrees. Okay, so that's what happens, or that's the representation for the letter grade of D. The letter grade of C is 2 out of 18 times 100. So what percent approximately is that one? Yeah, 11%. And again, if you then divide by the 100 and multiply by 360, what degree measure is that one?
40.
It's 40. Okay, we have two more. We have our 4 for the B's, 4 out of 18. Now, we should be able to do that without too much work, like if we were just needing the approximation, because it's just double the one we just did, right? So it should be 22%. But in terms of the next one, well, actually, we can do that too. We'll double the 40 degrees. If we double the 40 degrees, what do we get? 80. Yeah, so it's just double the one before, because it's the double number, the number of tests. And then the last one, the A's, are 9 out of 18, which is actually a really nice value. What's that? Yeah, that one's exactly 50%. Now you might notice as we're looking at this, because of rounding, this might not add up to a perfect 100%, right? Like that's a distinct possibility, and it's okay if it doesn't. It should still be close. Like if it's adding up to like 92%, we got a problem. But if you're within that, one on either side, 99 to 101, you're probably doing just fine. And then 50% of 360 is what? 180. Okay. Everybody good so far with the values that we got? All right. So I don't have a protractor, so let me borrow that one back from you, Amberly. So the protractors I handed out, they're all the same. If you have yours, it might look a little bit different. This one has a dot that's sort of an indentation on the bottom of it. Do you see that little dot where it's indented? That's where you would put that in the center of the circle. Okay, so wherever you marked the center of your circle, you're going to put that dot right there. Okay? The first thing that we're going to do is we're going to do the one that has the biggest degrees just because it's easiest. All right? 180 degrees on a circle. That's half of a circle, right? That's what the 50% here is representing. Agreed? So we can actually do the first one even without a protractor. You can just draw a line straight through the center of your circle in any way, shape, form you want. It just needs to go through the center. So draw your favorite line to cut through the center. And then on one side of it or the other, whichever side you want to represent your A's in this case, you're going to write A and you're going to write the percentage. You do not need to write the degree measure. If you want to, you can, but it's not necessary. So 50% of the class got A's. Does that make sense so far? Okay, now let me actually talk about how to use the protractor after that. We can't go from A to C, okay? I don't care whether you go from A to B or A to D, but they need to go in order one way or another. So let's actually just go up our list and go to the B's next for the 80 degrees. So again, your A can go from B here, and we can go from here to make our B, or we can go from here to make our B. It doesn't make any difference, so you can pick your favorite. And what you're going to do is you're going to line up that dot on the center, and you're going to line up the line that's on the bottom of the edge of the protractor on top of it. So I'm going to draw this on my screen now and let you have this back, Amberly. So visibly, your protractor kind of looks like this. It looks like it's lined up with that center piece right here, and there's a line coming out of it. Does that make sense? Okay. There are two numbers that are working their way up the side here. One of them is working their way up. It goes like 0, 10, 20, 30. The other one's working its way down. 180, 170, 160, 150. All good so far? We're using the one that's working our way up. And we're looking for it to equal 80. Now my picture, I don't have a way to do that because I don't have a built-in protractor in this program. But you're going to look for the one where over to this point it measures 80 degrees. And it's probably going to look something about like that. Okay? So what you're going to do, actually physically do, is you're going to put your protractor on there like I had before. And there's going to be an 80 degree mark, and it's going to say it's like right here or whatever. And you're just going to make the mark on the circle or somewhere. It doesn't even matter if it's on the circle or not. But you're going to make that mark somewhere nearby it or right next to it. Like if you want to make it just right there itself, you're going to make that mark at that 80 degrees. And after you've done that, you're going to connect that mark and that dot in the center, and that's going to form the line that you create. That's what that would look like. Now let me make mine a little bit more realistic by zooming out. So you're going to have a mark, something like that, that's going to represent 80 degrees, and that's going to be your B's, and your B's are 22%. Is that all right? Okay, then you're going to pick up your protractor and you're going to move it. The center is still going to be at the center of the circle, but now the line needs to line up on the line you just drew. So now here's my protractor, something like this. And again, I'm counting up and I'm measuring the letter grade for, or the percentage, not percentage, the degree mark for C's. I need it to stop at 40 degrees. So somewhere over here, approximately like that, let's say, is where it says 40 degrees, and you're going to again make your mark on the outside of the circle or outside of the protractor, and that mark connected with the point in the center are going to form a line segment, and that line segment will be something like, I have no idea if I'm dividing this well at this point at all, probably not. What do I have left? 40 and 60, is that what I have left? So we're going to go with that as I'm eyeballing it kind of thing. This would be our C's, and that represented 11%. Whatever your last category is should be that angle measure that's still trapped in there that we haven't labeled. You can double check it to make sure by simply moving the protractor again. You can either put the protractor along this line and measure just the way we were before. That's fine. Or you can put the protractor along the other line, and then you can measure going up this direction. It doesn't matter. You're looking to make sure that it's at 60 degrees or very close to it, that you haven't made an error in the other markings that you've made. Once you've confirmed that it is indeed 60 degrees or approximately so, this is the letter grade D, and the D's are 17%. Let's put a title on there, and I'm going to go ahead and finish this piece up. If you're still struggling maybe with the protractor, I'll be moving around and you can ask me and I can help you finish up your individual drawing. But we need a title still. That's the only other thing that we need. And just like the titles have been for all the sets of data, these are grades on a second exam. Any general questions about this? Yes, Jenna?
So you don't need like a set aside key for this one?
You don't. If you were doing something with a comparison, you probably would. We don't do that with this lesson, or with this graph, so you don't need one. Nope. Okay.